Neuralink, a name that's been making waves in the tech and medical fields, but what exactly is it? Simply put, Neuralink is a pioneering neurotechnology company masterminded by visionary Elon Musk. Its mission? To develop implantable brain-machine interfaces, often abbreviated as BMIs. These advanced devices aim to bridge the gap between our minds and machines, with the ultimate ambition of enhancing the human condition. But Neuralink's aspirations don't stop there. Imagine a world where humans could merge with artificial intelligence, where the boundaries between organic and synthetic intelligence become indistinguishable. This is the future Neuralink envisions. A future where neurological disorders could be a thing of the past, where the human brain's capabilities could be unlocked and expanded in unimaginable ways. This might sound like science fiction, but it's a journey that's already begun. Now that you have a basic understanding of what Neuralink is, let's delve deeper into the fascinating process of its implementation. Before the actual surgery, there are several key steps to ensure the success of the procedure. Our journey into the intricate world of Neuralink begins with a comprehensive pre-surgery preparation. This stage is crucial, serving as the foundation for a successful implantation. First off, a detailed brain mapping is conducted. This is not your average geographical mapping. Here we delve into the intricate labyrinth of the human brain, identifying specific areas responsible for various functions. It's like a GPS system for the surgeons, allowing them to navigate the complex neural landscape. The goal to pinpoint the perfect spot for the Neuralink device. Next, we move to MRI scans. These scans provide an in-depth, three-dimensional view of the brain. They're like high-definition photos, revealing every nook and cranny of the brain structure. The surgeons use these images to understand the patient's unique brain anatomy, identify any potential challenges, and plan the safest route for the implantation. Now, with the brain mapped and MRI scans in hand, the surgical procedure is planned in detail. Every move is strategized, every potential complication considered. This is a meticulously choreographed dance, where precision is paramount and there's no room for improvisation. The surgeons, armed with their extensive knowledge and state-of-the-art technology, prepare to embark on this neural expedition. You see, these pre-surgery preparations are not mere formalities. They are the pillars that support the entire Neuralink implantation process. They ensure that when the surgeons step into the operating room, they are not venturing into uncharted territory. They have a detailed map, a clear view, and a well-defined plan. With these preparations complete, we can now move on to the actual surgical process. The surgery, a critical juncture in the Neuralink implementation process, is where science truly meets art. And that artistry is crucial, as it's not just about placing a device in the brain, but doing so in a way that is as minimally invasive as possible. Let's delve into this intriguing process. The first step is the creation of a small hole in the skull. Now, when we say small, we're talking about a hole no larger than a coin. This is where the precision robot comes into play. The robot, armed with a high-speed drill, makes the incision with the utmost accuracy, ensuring the surrounding tissue is unharmed. Once the hole is made, the real magic begins. The Neuralink chip, which is about the size of a large coin, is inserted into this hole. But it's not just the chip that goes in. It comes with flexible threads that are thinner than a human hair. These threads, containing the electrodes that will interact with the brain's neurons, are guided into place by the same precision robot. This robot, a marvel of modern technology, delicately inserts the threads into the brain. This task requires a level of precision that simply cannot be achieved by the human hand. The robot avoids blood vessels, minimizing the likelihood of inflammation or other complications. Once the threads are in place, the Neuralink device is settled into the hole. The scalp is then closed up, leaving only a tiny portion of the device visible. The device itself is designed to sit flush with the skull, almost like it was always meant to be there. The entire process is designed to be as bloodless and painless as possible. In fact, the aim is for the surgery to be done without general anesthesia. That's right, patients could potentially be awake, chatting away while their brain gets fitted with the future of technology. Now, as amazing as this process sounds, it's important to note the surgery isn't the end. It's merely a chapter in the Neuralink story. After the device is fitted, there are crucial steps to be followed to ensure its functionality and the patient's well-being. The surgery is complete, but the process does not end here. There are critical post-surgery steps to ensure the device's functionality. Post-surgery, there are crucial steps to ensure the Neuralink device is functioning as intended. Once the Neuralink device is securely implanted within the brain, the post-surgery procedures commence. These procedures are designed to verify the successful placement of the device and to calibrate it for optimal performance. The first step in this process typically involves an MRI scan. This non-invasive imaging technique allows medical professionals to visualize the brain in high detail. It provides a clear picture of the Neuralink device's placement within the brain, verifying that it is in the correct location and has not moved during the surgery. It's a vital step, as an improperly placed device could result in suboptimal performance or potential health risks. Once the device's placement is confirmed, the next step is calibration. This involves adjusting the Neuralink device's settings to match the specific needs and brain activity of the patient. Each device is personalized, as everyone's brain is unique. This calibration process ensures that the device can accurately read and interpret the patient's neural activity. It's a delicate task, requiring the expertise of skilled professionals to fine-tune the device. Post-surgery, regular checkups are also part of the process to monitor the patient's health and device functionality. These checkups allow medical professionals to track the patient's recovery, observe any potential side effects, and make necessary adjustments to the device settings. Regular monitoring is crucial to ensure the device is working as intended and not causing any adverse effects. In addition to these steps, the patient may also undergo physical and cognitive therapy sessions. These sessions help the patient adapt to the device and learn how to use it effectively. It's a journey that requires patience and perseverance, but with the right support, it can lead to significant improvements in quality of life. Post-surgery procedures are as important as the surgery itself, ensuring the Neuralink device is functioning correctly and safely. It's a rigorous process, but one that is vital for the success of this groundbreaking technology. Neuralink's implementation process is an intricate dance of medical and technological expertise. This journey begins with rigorous pre-surgery preparations, where the patient's medical history and brain scans are scrutinized to ensure a safe and successful procedure. The importance of this phase cannot be overstated, as it sets the stage for the entire process and ensures that the patient is a suitable candidate for the implantation. The main event, the Neuralink surgery, is where the magic truly happens. It's a meticulous procedure that involves the implantation of the Neuralink device by a state-of-the-art neurosurgical robot. This robot, with its extraordinary precision, inserts the thin, flexible threads into the brain, carefully avoiding blood vessels and causing minimal disruption to brain tissue. The Neuralink device, a small chip, is then placed behind the ear, where it receives and transmits signals from the brain. After the surgery, we move into the post-surgery phase. This phase is equally significant, as it involves the calibration of the Neuralink device and the commencement of the recovery process for the patient. The device's settings are fine-tuned to match the patient's unique brain activity, while the patient is closely monitored to ensure a smooth recovery. Throughout each of these steps, the patient's safety and well-being are paramount. Every precaution is taken, every detail is given the utmost attention, and every potential risk is mitigated. This careful orchestration of medical and technological expertise is what makes the Neuralink implementation process so remarkable. As we conclude, it's important to remember that Neuralink is more than just a device. It's a beacon of hope for those with debilitating neurological conditions, a symbol of our relentless pursuit of knowledge, and a stepping stone towards a future where the boundaries between the human brain and technology blur. As we continue to push the boundaries of what's possible, Neuralink stands as a testament to the incredible potential of merging technology with the human brain. As we conclude our journey today at AI Future Hub, remember that you've stepped into the future where artificial intelligence shapes possibilities. Hope you've benefited from our cutting-edge content. If you haven't subscribed yet, now is the time. Show your support by hitting that like button. Share our videos and spread the future. Don't miss your chance to be with us again on this journey by subscribing, liking, and sharing. Until next time, keep exploring the future with us.